In today's video, we are going to be integrating by substitution. So in previous videos, we learned how to integrate, basic functions, but now we want to integrate with substitution. So in previous videos, we see that we can integrate f of ax plus b. For example, if we want to integrate that. So let's say we have a function ax plus b to the power of n. The integral of that is going to be 1 over a times ax plus b, and plus 1, remember we have to add the n and then divide it by that power and plus c obviously. And that only applies to only if the function inside is a linear function. So, functions like 3x plus 1 or 2 over 5x plus 4 or something. But in today's video, we're integrating something that is not linear. So for example, in our first question, we see that the inside function is not linear. So in order to do that, we need to integrate through substitution. So one of the things we do before we get started is first understand how to use substitution. So in this example, we want to replace this whole function inside to something else because we don't want that, right? We don't want this entire function because it's too complicated. So what we can do is we can take that and we call let u equals to this function. Let u equals to x squared plus 3x. And what we're going to do next is we want to derive that. So in order to derive that, du by dx, that's going to be 2x plus 3. Remember, that is the derivative, okay? And the next step we want to do is we see that there's a dx here, and we want to turn that into du. So in order to do that, we want to isolate dx. So to do that, I move dx to the other side. So you can pretend this as a regular fraction and it will work. So if we pretend it as a regular fraction, we're multiplying by dx. That leaves us with du. And remember, we want dx to be isolated. So dx is going to be 1 over 2x plus 3 du. So the next step we want to do is replace that dx into this entire function. So what we're going to do here is we have the function, and now instead of putting this complicated function here, I want to put that as u because we said let u equal to that. So we do u to the power of 4 times 2x plus 3 multiply by, instead of dx now, we want it to be this entire thing. So it's going to be times 1 over 2x plus 3 du. And if you take a look here, you notice that we have 2x plus 3, and we can cancel that out. So that leaves us with u to the power of 4 du. Wow, it's like magic, right? So the next step we want to do is we want to just derive that, okay? So to derive u to the power of 4, that's just going to be u to the power of 4 plus 1, which is 5, divided by 5. And remember, we have to plus c. And there you have it. If you want to change it back to x, you can always do that. So instead of u now, we can replace u back to x. So that gives us 1 over 5 times x squared plus 3x to the power of 5 plus c. And that is our first question. So now let's do our second question. This time, instead of an indefinite integral, we have the boundaries here. So we're doing a definite integral using substitution. So the steps that we do is very similar to what we did here. So the first thing we want to do is, again, identify what we want to substitute. So here I see we have x squared plus 1. That looks complicated, so I want that to be u. So u equals to x squared plus 1. And then again, we do the same thing as what we did earlier here, which is to derive it. So du by dx, in this case, is going to be 2x And remember, I want to isolate dx, so if I move dx to the other side, we have 2x times dx equals to du, and to isolate dx, we divide both sides by 2x. So there we have it. And now what we want to do is we want to put that in. But because this is a definite integral, what we want to do for now is ignore the boundaries. Now there are two ways we can do it. Let's do the first way. So the first method is we have to ignore the boundaries. So for now we just leave it like that, and we copy down the function, and we have to make sure we write in terms of u. So we have u to the power of 3 times dx, which in this case is 1 over 2x times du. And here I can see that I can simplify the function. So I can cancel out the x and 2, and that gives us 3 to the power of u cubed du. And in order to integrate that, first off, I want to not have the fraction, so I leave it as a negative exponent. And now what we want to do is when we integrate it, so first we integrate it, which is, in this case, we get u to the power of negative 2, 3 divided by that power. And in this case, we don't add c, remember, because it is it is a definite integral. And now we have notice that we ignored the boundaries. Now what we want to do is we want to add in the boundaries, and a lot of people make mistakes. What they do here is they copy down the exact same boundaries, but that is incorrect, because here, if we take a look at the function, the boundaries here are in terms of x, but here our function is in terms of u. So we have to change the boundary so that it is in terms of u. So we will make use of this equation for the boundaries. So for the lower boundary, we have 0. So what we do is we plug in x as 0. So 0 squared plus 1, which is just 1. And for the upper boundary, we do the same. We substitute 1 into x. So 1 squared plus 1 is equal to 2. So here we have our new boundaries, and that's what we're going to put that in. Now, the second method that you can do is so from here, I can, instead of making it in terms of u, I can make it back into x. So, for example, here, you see that we change the u back into the x. So here, we can do the same. So instead of u here, I want to have it in terms of x, so I have x squared plus 1, okay, to the power of negative 2. And then for the lower bound and upper bound, this time, because we changed it back to x, we will be using the same boundaries as the original equation. So we have 0 and 1. And these two are the same thing. If you plug it in, it's the same. So there you have it. This is an introduction to integration by substitution for both indefinite integral and definite integral. I hope this video helps, and I'll see you guys again next time. Thank you.